Hi, this is Angela Tobafunda. Student number is 162,426, and I'm here to talk about adaptive virtual texture rendering in Far Cry 4. So, Far Cry 4 has a large world. They divide this large world into two parts, being the near distance terrain and by far distance terrain. Far distance terrain is rendered by offline baked geometry and textures. So to enrich the look of their terrain, they would want to add procedural details onto their environment. So to do this, doing it deferred would be expensive, considering how large their world is and what quality it is. So since they have like a 10 by 10 kilometer world and then an insane amount of details, this would be really expensive to do deferredly. So to work around this, they would want to implement a procedural virtual texture to implement their additional details onto their terrain. So there are 3 steps on how to implement this procedural virtual texture. So you first allocate a virtual texture. So on the left side, this is how a virtual texture would look like. Then after allocating a virtual texture, you would use an indirection texture which maps from the virtual texture to the physical texture. And then on, since the physical texture size is configurable, there's going to be 3 of them, being normal, albedo, and specular. The information required for the virtual pages are then computed during the debuffer rendering pass. So after getting the information for the virtual pages, we then output a page index map into a full screen render target called page ID buffer. So after outputting the set information into a page ID buffer, we then analyze this on the CPU to see which pages are needed for which map level, and then allocating the physical texture pages to then render both terrain and details onto this same page. After all of that, we then want to update the indirection texture to be able to translate the virtual address to the physical address. So pages are being cached into our physical texture. They are cached based on what the least recently used is. So while in the cache, their terrain shader will just get the virtual textures and completely remove the calls for the terrain materials and details in the future. So this way we're saving memory but not compromising the amount of details that we can output on our screen. So we then use this indirection texture map from the virtual to physical UV, right? So each entry represents an entry from the virtual to the physical address. The contents of these textures is used to generate the physical memory location of the final texture page. So that makes rendering details from the texture materials and then the details more efficiently because it's only accessing 1 instead of 2. So motivation. So procedural virtual texture works well with caching the final rendering result of the terrain details as an optimization approach. But the problem is that since the virtual texture is applied, since the standard of the virtual texture applies to the virtual texture uniformly, they would just get 0.5 texel 0.5 texel per centimeter resolution. But that's not what they want because that's ridiculously low for the game. But on the other hand, achieving a 10 texel per centimeter resolution would not be possible considering the size of their world and the ability of platforms to render this. Like, it's just not possible at all without compromising the size of the actual, yeah, it's not possible at all, basically. So to do this, to work around this problem, they decided to implement another technique called adaptive virtual textures. So adaptive virtual textures are based on procedural virtual textures. So since they only need the 10 texel per centimeter for when it is very close to the camera. Yeah, never mind. Wait, let me rephrase that. Okay, since they don't really need 10 texel per centimeter for everything in the world, they would just like use which parts of the scene needs 10 texels per centimeter. So it's only gonna be 10 texels if it's close to the camera. It can go as less as 5 if it's a bit further away from the camera, and then it can even go less than that if it's really far away from the camera, since we don't need that much detail and quality resolution on our textures. So this way, the virtual textures won't apply uniformly to the overall scene, making it like possible to achieve good resolution on our virtual textures. Yeah. So bottom line is, adaptive virtual texture rendering will like improve our texture resolution. So how they use it in game is that they divide their world into multiple sectors. So being near terrain, and then like far terrain, and something along the middle. Not really. It's near and far only. Yeah, never mind. So, yeah. So they divide the world, right? So for their near terrain, they would just allocate the virtual image just like being a square on the texture for each of them inside the texture. If that sector is closer to the camera, that said virtual image would increase size on our virtual texture map. So that's basically how they do it. So depending on how close the sector is, it's gonna have a larger virtual image onto their map. So that's basically how they implemented their terrain as well as their details on it. Yeah, thank you for watching. I hope you have a good day.